Hi, this is your Professor Sudha Kolathuparambil, Section 8.3 Confidence Interval for a Population Proportion. So, in Section 8.1 and 8.2, you already learned how to find the confidence interval for a population mean when standard deviation is known and when standard deviation is unknown. So, here we are going to learn how to construct a confidence interval for a population proportion and find the sample size necessary to obtain the confidence interval of a given width, and describe a method of constructing confidence interval with small samples. Let's look at objective 1, construct a confidence interval for a population proportion. Does learning music improve your grade? The National Association of Music Merchants surveyed 800 parents of children 5 to 18 and 632 of them said that the music education has a positive effect on the academic performance. Assuming these parents to be random sample, we would like to construct a confidence interval for the proportion of parents who believes that the education has a positive effect on academic performance. This is an example of a population whose items falls into two categories. So here the categories are those parents who believe that the music education has a positive effect on the academic performance and those who don't. We are interested in the population proportion of those who believe that there is a positive effect. Let's look at the notations. P represents the population proportions of individuals who are in a specified category. X is the number of individuals in the sample who are in the specified category. N is the sample size. P hat is the sample proportion of individuals who are in the specified category. P hat is X over N. P hat, so hat means P is wearing a hat or a cap, it's like that. That's why we call it as P hat. So P hat is X over N. And remember, P represents the population proportion and P hat represents the sample proportion. So now let's construct the confidence interval. So confidence interval is similar to the previous sections. Same formula, the point estimate plus or minus the margin of error. And the margin of error is actually the standard error multiplied by the critical value. The point estimate we use for the population proportion P is the sample proportion, which is P hat equal X over N. Now we need to find the standard error. In section 7.4, we found that when the sample size N is large enough, the sample proportion P hat is approximately normal with the standard deviation square root of P times 1 minus P divided by N. In practice, we don't know the value of P. So while constructing the confidence interval for population proportion, we replace this P with the P hat. So the standard error will be square root of P hat times 1 minus P hat divided by N. The population proportion P is unknown. The sample proportion P hat is known. And we use the value of P hat to estimate the unknown value of P. That means we replace this P with P hat. That is our standard error. Now multiply the standard error with the critical value Z alpha over 2 to get the margin of error. So margin of error is, so now we can conclude the confidence interval is add these two point estimate plus the margin of error. The method I just described here requires certain assumptions. So let's look at the assumptions now. The assumptions for constructing a confidence interval for P is, we have a simple random sample. The population is at least 20 times as large as the sample. The items in the populations are divided into two categories. Sample must contain at least 10 individuals in each category. So check to assure that the assumptions are satisfied. If they are, then proceed with the steps to find the confidence interval. The population must be much larger than the sample, that means at least 20 times as large, so that the sampled items are independent. The assumption that there are at least 10 items in each category is an approximate check on the assumption that both NP and N times and 1 minus P are at least 10, which assures that the sampling distribution of P cap is approximately normal. When constructing a confidence interval for a proportion, round the final result to 3 decimal places. If all the assumptions are met, then proceed with the step to find the confidence interval. Now let's look at an example of how to construct a confidence interval for a proportion. In a survey of 800 parents, 632 said the music education has a positive effect on the academic performance. We need to construct a 95% confidence interval for the proportion of parents who believe that the education has a positive effect. We begin by checking the assumption. We have a simple random sample. It is reasonable to believe that the population of parents in the United States is at least 20 times as large as the sample. So the items in the population can be divided into two categories. One who believes that and one who does not believe. So there are 632 parents who believe that the music education has a positive effect, which is greater than or equal to 10. Then if you subtract that from 800, we will get the parents who does not believe. So that is 168, that is also greater than 10. So I am going to start with the formula for constructing the confidence interval. So that is point estimate plus or minus the margin of error. Now let's see what are the things given and what we need to find out. The sample size is n, that is equal 800, and the number of who believe that the video game have a positive effect is x, that is equal 632. P hat is x divided by n. So if you look at the formula, we know P cap now and we know n, but we need to find out the critical value. So we need to find the critical number for 95% confidence interval. So this is 95%, that is 0.95, area is 0.95. So sum of these two areas will be 5%. These two are of the same area, so this area is area on the right side of z alpha over 2 is 5% divided by 2, that is 2.5%. So the area in decimal is 0.025. We can use the INV norm command on TI-84 calculator to calculate the z-score corresponding to the area on the left side of the z-score. So area on the left side of z-score is, this area is 0.025, right? So this entire area will be 1 minus 0.025, that is 0.975. So using the calculator, press second wards option 3 INV norm, then enter the area to the left side of the z-score and comma, then mean, comma, the standard deviation. Then press enter, you will get the z-score as 1.96 if you round it to 2 decimal places. Now we can construct the 95% confidence interval. So now substitute the values for p hat, critical value, and n, and find the interval. Now you will get two values. If you add this value, you will get 0.818, and if you subtract, you will get 0.762. I rounded the answer to 3 decimal places. Note that you should round only the final result, not the calculation you have made along the way. Now we can interpret the result. We are 95% confident that the proportion of parents who believe that the music education has a positive effect is between 0.762 and 0.818. Now let's see, a music teacher claims that 80% of parents believes that the education has a positive effect. Does this confidence interval contradict the claim? Since the 80%, that means 80% in decimal is 0.80, right? That is within this interval. So the confidence interval does not contradict the claim. Constructing confidence intervals using TI-84 plus calculator. First press stat, then test, then select option A. Option A, if you select, it will bring it to the screen. There you can enter X equals 632, N equal 800, and C level. Confidence interval is 95%, so 0.95. Then highlight, calculate, and press enter. So while selecting this, you cannot see A in the beginning. You have to use the arrow key. So first you will see all the numbers, 8, 9, then 0, then start the alphabet A, B, C, like that. So select option A. You can round your answer into 3 decimal places. Objective 2. Find the sample size necessary to obtain a confidence interval of a given width. That means we need to find n. So we already know the margin of error formula. So using this formula, solve for n. So I just copied this formula here. Now first I am going to divide both sides by z alpha over 2. So this will cancel out. Now square both sides. Now take the reciprocal on both sides. So that is basically flip each fraction. There will be more than one way to do this problem. If you want, you can multiply both sides by n. Then divide by this whole thing. You can do that. Here what I did is I took the reciprocal on both sides. Then I need to get n by itself. So multiply both sides of the equation by this whole thing, p hat times 1 minus p hat, so that we will get n by itself. So this is the formula for the sample size. So this is the minimum sample size needed to attain a margin of error of size m. If this value of n is not a whole number, you can round up to the nearest whole number. So we just learned the formula for finding n, the sample size, that is p cap 1 minus p cap times z alpha over 2 divided by m whole square. So this is the minimum sample size needed. In order to use this formula, we need to find the value of p cap and we need to know the value of m. But we don't know ahead of time what p cap is going to be. So there are two ways to determine the value of p cap. One is to use a value that is available from a previously drawn sample. The other is to assume that p cap is 0.5. So if p cap is 0.5, this is 0.5, 1 minus 0.5, that is also 0.5. So if you multiply these two, you will get that is equal 0.25. So we will use this formula to calculate the sample size. when P cap is not available. And remember that we always round up n if n is not a whole number. This is an example to find the necessary sample size. So in a survey of 800 music teachers, 632 said that the music education has a positive effect on the academic performance. We need to estimate the sample size needed so that the 95% confidence intervals will have a margin of error 0.025. So I am going to start with the formula for sample size. Sample size n equal P cap 1 minus P cap z alpha over 2 divided by m square. First calculate P cap. P cap is 632 divided by 800, which is 0.79. Z alpha over 2, that is the critical value. At 95% confidence interval is 1.96. You can use a table or you can use a calculator to find that. If you are using a calculator, it will be the second was option 3. So this area is 95%, so this will be, sum of these two areas will be 5%. So this is half of 5%, so 2.5%. So this area is 0.025, but we need to find the area to the left side. So that is 0.95 plus 0.025, so 0.975, then mean mu sigma. So if you enter that into the calculator, you will get the critical value. Otherwise, you can use the table to find the critical value. So critical value is z alpha over 2, that is 1.96. So right now we know the P cap, we know z alpha over 2, that is the critical value, and m, that is the margin of error. Okay, that is given here, so we can use that value. Now substitute all these into this formula and calculate. So now round up, so 1020. So we estimate that we need to sample 1020 parents to obtain a 95% confidence interval with a margin of error of 0.025. This is another example to find the necessary sample size. Here P hat is not available. We plan to sample parents in order to construct a 95% confidence interval for the proportion who believe that the physical education has a positive effect on the academic performance. We have no value of P cap available. Estimate the sample size needed so that 95% confidence interval will have a margin of error 0.025. So here the desired level is 95%. So we can find the critical value. 95% confidence interval is 1.96. You can use the table or calculator to find that. If you are using the calculator, second was option 3, that is INB norm 0.075, 0, 1. So you learned this in chapter 7. If you don't remember how to find the critical value, you can refer that chapter 7.1. Margin of error is given m equal 0.025. Since P cap is not given, we assume that P cap is 0.5. So in this formula, we substitute the values and we round up to 1537. So since the p cap was not given, that's why we assume that p cap is 0.5. So we estimate that we need a sample of 1537 parents to obtain a 95% confidence interval with the margin of error 0.025. This estimate is larger than the one in the previous example because we used a value 0.05 for p cap, which provides a sample size large enough to guarantee that the margin of error will be greater than 0.025 no matter what the true value of p is. Objective 3. Describe a method for constructing confidence interval with small samples. The method you just learned, constructing the confidence interval for a proportion, requires that we have at least 10 individuals in each category. When this condition is not met, we can still construct a confidence interval by adjusting the sample proportion a bit. So we increase the number of individuals in each category by 2. So that the sample size increase by 4. Because total we are adding 2 in each category. So sample size will be increased by 4. So the new adjusted sample proportion will be, instead of x over n, we will have x plus 2 divided by n plus 4. The adjusted sample proportion is written as p tilde. This is how we pronounce tilde, and this is the notation for that, a small mustache on top of p. And remember, sample proportion is p hat, a small cap on top of p, and this is a small mustache on top of p. Now let's look at the method for constructing confidence interval with small samples. You have already learned the method to construct the confidence interval for population proportion using this formula. In the small sample method, we will replace this p hat by p tilde, and we will replace this n with n plus 4. Then the confidence interval for the population proportion will become like this. Now let's look at an example. In a random sample of 10 businesses in a certain city, 6 of them had more than 15 employees. Use the small sample method to construct 95% confidence interval for the proportion of businesses in the city that have more than 15 employees. Here n is 10 and x is 6. So this is a small sample. So adjusted sample proportion will be, critical value is z alpha over 2, and that is equal 1.96 at the 95% confidence level. Now we can substitute these values into the formula to find the confidence interval. We will get two values for this. If you add, you will get 0.831, and if you subtract this whole thing from this, you will get 0.312. So the interval is 0.312 less than p less than 0.831. Small sample method using the TI-84 calculator. So first press stat, then test, then option A, that is 1 prop z int, and for x and n, for x you will enter x plus 2, and for n you will enter n plus 4. These values will be known, x and n will be given. So compared to the previous example, we will enter x equal 8 and n equal 14 and c level 0.95, then calculate and round your answer to 3 decimal places. There are some advantages of the small sample method. Small sample method can be used for any sample size, And recent research has shown that it has two advantages over the traditional method. First one is the margin of error is smaller because we are dividing by n plus 4 rather than n. Second is the actual probability that the small sample confidence interval covers the true proportion is most always at least as great as or greater than that of the traditional method. This holds for confidence level of 90% or more, which are the levels commonly used in practice. So in this section you learn how to construct and interpret confidence interval for a population proportion. And the assumptions are, it has 4 assumptions. We have a simple random sample and population is at least 20 times as large as the sample. Items in population are divided into 2 categories and the sample must contain at least 10 individuals in each category. Then you learn how to find the sample size necessary to obtain a given confidence interval for a population proportion of a given width when p hat exists and when p hat is not available. When p hat is available, this is the formula we use. When p hat is not available, we assume that p hat is 0.5 and we replace this p hat with 0.5 and this formula will become like this. Then at the end we learn how to construct the confidence interval for population proportion with small samples. Here we increase the sample size in each category by 2 so that the sample size increase by 4.